Um, Looking at our requirements here, we had to meet a height of the slide at 14 meters. Our angle from horizon needed to be 10 degrees. We were using a open slash serpentine type of slide. We had a water supply size of 70 cubic meters. The rider mechanism is a mat. Our material is made of fiberglass, and then we're uh, have an age range of users of 10 to 15 years of age. And so the first thing we kind of did is we determined how much area of water would be in the slide at any given time. And so that's kind of what is going on in question number one, because we had to meet and find out what the specifications of our slide would actually be. So we determined that the minimum width is 22 inches inside the sidewall. Minimal sidewall height has to be 16 inches. Sidewalls that are straight and from vertical have a maximum of 6 inches, measured at 16 inches from the bottom. And so we did all that, and then we also found that the minimum water depth always has to be at least 2 inches to be able to flow through the entire thing. So to calculate that all, we found out that at one given point in the slide, it will always have 30.1175 cubic inches, or not cubic, squared inches of area of water in the slide at one time to be able to adhere to these standards. And so the pump we chose to be able to do that is a Fill-Rite FR 421 G 12 volt DC fuel transfer pump. It's just a quarter horsepower pump. It has a flow rate of 20 gallons per minute. It's made out of cast iron. So the motor kind of already comes with the pump, and it's a UL approved motor. And so doing the calculations to determine how much gallons of water are required by our design. So we found out what the length of our entire slide was, which is 80.62 meters. And so what we ended up doing is you can take that 80.62 meters and multiply it by your area within the slide, which we converted to meters, which is 0.0004935. And that gives us a total cubic meter of 0.0397. Which, if you add that to our reservoir, that gives us a total of 18,502 gallons. And so basically the amount of gallons of water that need to be pumped in at any time to maintain a safe flow. If we take that multiplied by 264.17 gallons per meter cubed, it gives us about 10 gallons, but we wanted to pump 20 gallons just to be safe.
So, according to the standard we found, the velocity of water should be no more than 50 feet per second to safely transport the passengers. And the maximum speed of the each riders should be traveling down the slides. For this question, we assume that each body is experiencing the same energy all the time. So we presumably using the kinetic energy equals to the potential energy, which gives us a velocity of 7 meters per second. Based on our slide area, we conclude that 6.5 inches diameter pipe size will be suitable in our case. And for the valve, we choose a motorized flange water slide gate valve to smartly control our flow. For the flow meter, we choose a compact type flow meters, which gives us up to 7 gallons per minute uh, capability to measure our fluid performance, and of course, other equipments like necessary pipe adapters and fixtures are needed to connect all the components.
Now going into number 8 for how long the experience will ride. We took the length of the entire slide, which was 80.62 meters, and divided that by how fast the person was going to be going, which is 7 meters per second. And that's where you get your 11.52 seconds. And then leading right into number 9, we just figured it would be safe to send the next person down right after the person is done with the slide. That would give the person at the bottom of the slide more than enough time to get out of the slide and get out of the reservoir area and out of the pool and safely, so the next person can go down. The height requirements, what we did was we researched the average height of a 10-year-old, which is around 53 inches. So we were just working with the plus minus range, I guess, and just brought it down to 48 inches for our age group, which is a 10 to 15 age, 10 to 15 years old. So yeah, the height requirement for this ride is 48 inches. Going down into number 11, if you can see down here, this is just goes over the cost of all the equipment, the slide materials, and just how much the project is going to cost. The main part of this cost is just the material cost since we're using fiberglass. That was a huge expense, and it totaled out to around 25,000 for the full project cost. Yeah, and then going down to number 12, to keep this slide operating annually, what we calculated is that it came around to $391 a year to operate this, and that's how much the electricity is going to cost. You can work through the math since it shows right there. It's gonna be operating around 70 hours a week. It's gonna need 0.48 kilowatts, and yeah. So since the pump that we used, it's only gonna cost $391. But if we were to use a motor with 1 horsepower, since ours was used on quarter horsepower, the annual cost would have been 4 times greater at $1,565. So we saved, what is that? A lot of dollars. So nearly $1,100 right there. But yeah. So for a total expense, it seems like it's around 25,000 and roughly 500 for the first year in costs.
Mhm.
And yeah.
Awesome. I think that's it, Yvonne.
Okay.
Cool. So
Cool.
yeah, if you want to trim that up, like I guess that last bit or something.